Statics example 7. In this example, we're starting to consider the impact of friction when we're looking at an object that is in equilibrium. We've got here a block of mass 3 kilograms, which is resting on a rough horizontal plane. As we read the question, if we just put the forces on as we go through, so the weight is going to be 3g, and that means that there would be a normal reaction too. The coefficient of friction is 0.4, so we'll jot that down for later. 0.4. A horizontal force, P, is applied to the block. And it says that the block remains in equilibrium. Now that would only be true if the friction acting on the block was sufficient to ensure that P did not make the block move. Now, if you remember from when we did dynamics, if something is in limiting equilibrium, which is what's being mentioned in part A, then F is equal to mu r. So if an object is on the point of moving but it hasn't started to move, it's reached its maximum value of friction, and we call that limiting equilibrium. So in this case, we've got to find the value of P for which equilibrium is limiting. Okay, so if we resolve vertically to start off with, we can see that the normal reaction will be 3g, and so the friction acting on this particular object would be equal to mu r, which is 0.4 times 3g, which works out to be 11.76. Now, if we look at the situation horizontally, if something's in limiting equilibrium, it means the forces acting in the two different directions are balanced. You could think about this as saying F equals ma to the right, and you could say that the resultant force is P minus friction, and that would be equal to the mass times the acceleration, which is 0. It isn't moving. Or you can just go straight to the stage where you say forces to the right would be equal to forces to the left. So if we know that P is equal to the value of friction, we know that that's 11.76, and because we've involved G in this question, we should really give our answer to two significant figures. So that would work out to be 12 newtons. So that's part A. Now for part B, it says find out the value of F, that's the frictional force, when P is 8. Now we know that the object is on the point of moving when P is 12, or 11.76 to be precise. If we apply a smaller force, that means that we don't need as much friction in order to keep the object stationary. And in fact, if we were to do F equals ma to the right again, we'll see that P minus the friction would be equal to 3 times 0. The object isn't moving. The reason we know it's not moving is because it's in limiting equilibrium when we apply a force of 12. So if we're only applying a force of 8, that won't be sufficient to make it move. It would have to be bigger than 12 to make it move. So once again, P is equal to friction. And so if P is 8, that means your frictional force would only need to be 8 newtons in order to keep the object stationary.